Assalamualaikum warahmatullahi wabarakatuh. Welcome to our presentation. We are from Group 2, Section 1 of Fluid Mechanics, and we are going to present about our finding on hydraulic braking system. First and foremost, this is our group member. Me, Muhammad Ridwan bin Asmizam, will present with my fellow friends Dinesh Varma Tevar anak lelaki Rajendran, Fat Amirul Nizam bin Syahrul Nizam, and Muhammad Faiz bin Yahya. This is our contents that include introduction to braking system, the design and component of the system, the operation and how the system works, how fluid mechanics principles apply in the braking systems, and conclusion.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present you about hydraulic braking system. We from Group 1, Group 2, Section 1. Lecturer Madam Siti Mariam binti Bashari. Okay, go for the introduction. This is our group members: Muhammad Rizwan bin Asmizam, Dinesh Varma Tevar anak lelaki Rajendran, Fat Amirul Nizam bin Syahrul Nizam, and me, Muhammad Faiz bin Yahya. Okay, this is our content. First, introduction to braking system. Second, the design and components of the system, the operation and how the system works, and how fluid mechanics principle apply in the braking system. And then lastly is a conclusion. Okay, for the introduction to braking system, we can look at this slide. Hydraulic braking system work based on the transmission of force through an incompressible fluid. The principle used in Pascal's law, which state that pressure applied to a confined fluid is transmitted equally in all directions. This is a hydraulic principle. A small force at pedal, then multiply force at wheels. And a fluid use is incompressible for efficient transmission. And then hydraulic principle provide smooth and uniform braking. So the hydraulic braking system apply fluid mechanics principle to transmit pressure and amplify braking force effectively.
Now I will present about the design and components of the system. First, the input or master cylinder. The function of this, the input, is to convert mechanical leverage into hydraulic pressure. The components that contains in this design is brake lever or pedal, reservoir, and primary piston. The fluid that is present is incompressible brake fluid, example BOT4, acting as the energy in. Second, the transfer or hydraulic lines. The principle uses Pascal's law. Pressure is applied to a confined fluid is transmitted equally throughout the system. Design reinforced hoses to prevent expansion, ensuring all force reaches the brake unit without loss. And final, the output caliper and actuator. The caliper acts as a clamp, houses slave pieces that receive the fluid pressure, and the friction pair, which is the brake pad, press against the rotor or disc, converting kinetic energy into heat to stop the rotation.
Now I'm going to show you the operation and how the system works. First, an object, or in this case the force, is applied to the brake pedals, which enables the brake master. When it is at the brake master cylinder, the force that applied on the brake pedals will convert to a hydraulic pressure. The hydraulic pressure that has been converted is then transferred to the brake calipers. From the brake calipers, it will push the pistons inside the calipers towards the brake pads. Once it's pushed the brake pads to the disc, it will start to be mounted onto the disc. Then the disc is connected to the wheels of the car, and it will start to slow down the movement of the vehicles.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ridwan bin Asmizam, and I'm going to continue on how fluid mechanics principle apply in the braking system. So basically, braking system is using Pascal's law, which is P equal to F per A. So when you press the brake pedal, the force is applied to brake fluid, and this pressure is transmitted equally in all directions through the fluid. So meaning that a small force from the small area can resulting to a bigger force, which I include a simple example there. Let pedal piston area is 2 cm square. Wheel piston area is 10 cm square. So the given force is 100 Newton at the pedal piston area. So we put it in the Pascal's law formula, which is P equal to F per A. So we make an equation P1 equal to P2. So P1 is, you can assume it as F1 per A1 and equal to F2 per A2. So just put the information, which is 100 per 2 equal to F2. We have to find the F2, so just put the information there. 100 per 2 equal to F2 per 10. So we get F2 equal to 500 Newton. So this means small forces that apply on the area, a small area, resulting to a bigger force with a bigger area. So that's how braking system or the Pascal law are applied in the braking system. That's all from me. Thank you.
For conclusion, the hydraulic braking system is an efficient and reliable method for slowing down or stopping a vehicle by using the principle of Pascal's law. When the driver presses the brake pedal, a force is applied to the master cylinder, which increases the pressure of incompressible brake fluid. This pressure is transmitted equally through the brake lines to the wheel cylinders of calipers at each wheels. This is the illustrate of mechanism of hydraulic braking system.